Welcome to Get Your FRQ On. This question is from 2005. It's question 1, and it is calculator active. In the question stem, we're given two functions and a graph on a small interval, and we have to find the area of a region R. Now, the graph that's provided shows these two functions intersecting in more than one point, and so two different regions are defined when we talk about area bounded between the curves. R is the first region to the left of the two that we're interested in. So in order to find the area of R, we need to know the appropriate upper and lower bounds to integrate. All right, so in order to find the area of R, we need to know the bounds of integration. The lower bound is 0, that's evident from the graph, and the upper bound is just going to be the x-coordinate of the point where the two functions f of x and g of x intersect, or at least the lower of the two. But this is a calculator active question, so we can use our calculator to find that point of intersection. All right, so the two functions actually intersect twice, once at x equals 0.17822 and another time at x equals 1. We want the lower of those two values for this problem. So given the graph, the upper boundary of the region R comes from the graph of g of x, and the lower boundary comes from the graph of f of x. And for simplicity, let's define a to be the number 0.17822. So the area of the region R is the integral from 0 to a of g of x minus f of x dx, which is equal to the integral from 0 to a of 4 to the negative x minus 1/4 plus sine of pi x dx. And because this is a calculator active, we are 100% going to use our calculator to do this. You might be able to do it by hand, maybe, but I don't know, the decimals, and it's calculator active. There's no point in trying to do it by hand. So we let the calculator do the work, and that region has area 0.065. In part B of the question, we are asked to find the area of region S. Region S is just the region further to the right of region R, and that one should start at the value of a and continue all the way to x equals 1. All right, so the region S is a lower bound of our value of a, which we've already defined, and an upper bound of 1. At this point, however, the curve of f of x is now the upper boundary, and the curve of g of x is the lower boundary. All right, so this is a calculator active question, so we are going to use our calculators. We need the integral from a to 1 of, and then notice the transposition of the two functions here, since f is now the function on top and g of x is now the function on the bottom. We have the integral from a to 1 of 1/4 plus sine of pi x minus 4 to the negative x dx, and that is 0.410. In part C of this question, we are asked to find the volume when this region S is revolved around the line y equals -1. Now, because y equals -1 is below the x-axis, the function that's going to provide our outer radius is the one that's further above the x-axis. So if S is revolved around the line y equals -1, our outer radius will be given by the expression -1 minus f of x, since f of x is actually the one that's greater than g of x. And our inner radius will be given by -1 minus g of x. All right, so we need to evaluate the definite integral, pi, times the integral from a to 1 of our big radius function squared minus our little radius function squared, which is provided -1 minus f of x squared minus -1 minus g of x squared dx. But again, this is a calculator active question. Use your calculator. The value of that integral is 4.559. So that would be the volume of the region S when it is revolved around the line y equals -1.